Hi guys, Raz here, and today we'll be looking at bounds. So bounds is a grade sort of 7, 8 plus topic, a bit of an icing on the cake topic if you ask me. So before I get into some worked examples, I'm going to yap for a little bit. Watch the introduction video if you're not sure about what I'm about to quaffle about. So I'm going to look at certain amounts. I'm going to look to maximize and minimize them. Yes. So I'm going to play around with values of A, B, and C, which could have been rounded from various things, whether it been from two significant figures or one significant figure or two decimal places, etc. And we would obviously then get an A min and an A max, a B min and a B max, and a C min and a C max. Yeah, so rather than look at the numbers, this preamble, is just going to be us doing a solution in words. So the first one I'm going to start with is if we were looking to maximize and minimize something straightforward like A times B plus C. Well, to maximize that, I think we'd all see that we need the biggest A times by the biggest C plus the biggest B. Yeah, and likewise to minimize it, we'd need A min times B min plus C min. So hopefully you know what I'm on about now. I'm going to make that a little bit harder and change the sign. Oops. So if I change the sign, it gets a little bit difficult, or more difficult than the previous one. And to maximize, we'll still need A max, but this time to get the biggest possible value in the bracket, we need the biggest C, sorry, the biggest B minus the smallest C. Likewise, if we're to minimize that amount, we'll need the smallest A, so A min, multiplied by the smallest value, which will be the smallest B, take away the biggest C. Yeah, and this is the concept that we're going to lead into with numbers shortly. So if we had a fraction, let's say A over B, we want to maximize it. The concept of sharing means if I'm sharing something with someone, I want to get more, I give them less. Yeah. So I'll get the biggest piece, the biggest amount divided by the smallest possible amount. So B min. So if I were doing the minimum, if I'm trying to minimize that fraction, we'll have the minimum A divided by the maximum B. So if we pick a different amount, a different type of fraction, let's say A over B plus C. So if I want to maximize that, I'd have the biggest A on top divided by the smallest denominator, which would be B min plus C min. So to minimize it, I'd need the smallest A divided by the biggest denominator, which would be B max plus C max. And the last one I'm going to consider would be that. So again, to maximize that fraction, we need the biggest top divided by the smallest bottom. The smallest bottom would be have the smallest amount, B min, take away the biggest amount, C max. And if we're trying to minimize that result, we'd need the smallest amount on top divided by the biggest possible value, which we get by taking the biggest B and take away the smallest C. Yes, I hope that makes sense. Feel free to take some notes on that bit. So let's just go into some examples now. I'm going to look to do 3. So this first one here. So this first one here, and we want to find the question is asking us to find the upper bound. Yes, that'd be A max. So the first thing I'm going to do is just write it out in words. A max is B max divided by C min. Now, I'm going to write down the values with an inequality. So 95, my secret is just add a decimal place, add a digit, must be between 95.5 and 94.5. Yeah, so bounds always end in fives. So if you add that place, you just have to go 5 more and 5 less. So I've got a 9 for C, so I've got 9.0. 5 more, 9.5, 5 less, 8.5. So in this one, I need B max and C min. Now let's get cracking. So A max is 5 times 95.5 divided by 8.5. Let's get the old calculator out. Type that in. Oh. Type that in. And we have 5 times 95.5 divided by 8.5. And that gives us 56.176. Yeah, I hope that makes sense. Let's do another one. So next one, we'll do the upper bound for this one. So like before, I'm going to write what we need in words. We have X max equals 4 times Y max divided by Z minimum. Yeah, because we're trying to find the upper. If we were trying to find the lower, we would have done X min equals 4Y min over Z max. Yeah, but we haven't been asked to do that, so I can get rid of that one. Next thing I'm going to do is write the inequalities out to make it easy for myself. So I've got 30.3. I'm going to stick the extra 0 in. I just have to go 5 more. 30.35. 5 less than 30 is 30.25. I've got 0.7, stick the extra digit. So I'm going to have a 0.75 and a 0.65. This question I need Y max, which is there, and I need Z min, which is there. So X max must equal 4 times 30.35 divided by 0.65. Let's get the calculator, plug that in. I'll just make it disappear somehow. Plug that in. And we've got, so 4 times 30.35 divided by 0.65 gives us 186.769. Okay, last one. This next one is often worth 5 marks, yeah? And the difference here is don't ask us for an upper bound or a lower bound. I said by considering bounds, round it to a suitable degree of accuracy. So what that means is we need to find both. Yeah, the first step to do is find both. So when it says considering bounds, you need to consider them. So find the upper bound and the lower bound. So before I do anything, I'm going to write this bit out. So 5 more than 0.07 would be 0.075. And then less than that 70 would be a 65. We have an 82. And put a 0 there, so I need a 0.0825, and I need 5 less than 20, which is 15. So 0.0815. Now, we're going to do both here. So if we consider the upper, we need P max will be root Q max divided by R minimum, and P min will be root Q min over R maximum. So I need Q max, which is 0.075 rooted divided by R min, which is 0.0815. And the minimum for P will be Q min, 0.065 rooted divided by R max, which is 0.0825. So we'll get two separate answers. And which are square root 0.075 all over 0.0815 gives me 3.36. I'm going to write a few decimals in, you'll see why in a minute. And then I need to do the minimum as well. So change that to a 25 and the other one to a 65. Delete 6. So 3.09031, blah, 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 blah. We don't need a calculator now. So what we need to do, so say we've probably got 4 out of 5 marks here. And you can see with my working how, if you work this way, how easy it is for the examiner to see what's going on. So hopefully with 4 out of 5 marks here, we've got 1 bit to do. So if I round these numbers to 3 decimal places, for example, 3 decimal places, I would get 3.360 and 3.090. Is that the same? Hell no. Let's go 2 decimal places. We're going to get 3.36 and 3.09. Are those the same? Hell no. Let's go to 1 decimal place. Are they the same? 3.4 and 3.1. No. But what will they round the same to? Exactly, 1 significant figure. So by considering bounds, work out the value of P, giving your answer to a suitable degree of accuracy. For this would be 3. The degree of accuracy would be 1 significant figure. Yeah, so I hope you understand bounds a lot better and you realise how to structure your work. Catch you again soon. Bye.